Right, time for our next lecture, and this time I'm going to be talking about TypeScript. And TypeScript for JavaScript programmers should be something that is on your mind. And this is something that you probably, once you graduate, you're going to want to go and actually learn and study TypeScript on your own. We unfortunately don't have any actual exercises in this course on it yet, though I have a secret desire to switch the entire curriculum over to TypeScript probably in the fall, maybe later. But one reason I think I can be successful at that, I'll get to in a second when I talk about its popularity. But TypeScript was a language that was developed, it was first introduced in 2012 by Microsoft. Now, JavaScript, as I've mentioned before, is a pretty nasty language, especially the original language had a lot of problems. But in its defense, it was designed to just be something where you write, 5 or 10 lines of code here and there, and you use it to add a little bit of interactivity on your web page. So it didn't need to be a fully professional language. It just needed to be something that you could use in these small cases. And as it started getting more and more, as JavaScript started growing in popularity and started to get used more and more to make not just mildly interactive web pages, but to draw the entire page and to manipulate the DOM, and then it started getting used back on the server to do server stuff with Node, and its warts and its problems just became very, very obvious, and a lot of improvements were made to the language over the years. But one of the things that has never been introduced to JavaScript yet, though there is now a proposal out to do it, but one of the things that has never been introduced is adding static typing to your variables. Like in JavaScript now, all your variables, you don't know what type they are. There's no way that the compiler knows what they are. You just find out at runtime. And what you think might be think is a number turns out to be a string, and it has all kinds of problems and so on. And so when you're writing large-scale programs, this is very, very problematic, because that type checking is amazingly valuable, and being able to do the static checking of your code correctness at compile time, actually even while you're typing in your editor, getting all that feedback and information is extraordinarily valuable for writing large-scale programs. And so that's what that's the main value that TypeScript provides, is this ability to describe all your types in JavaScript and make sure that as you're calling functions and passing variables around, that the types match up and that you're making correct calls. So just quickly, how many, what in your experience, as limited as it is the most common bug that you have to fight with? Yes. Typos. Okay. All right. Typos is a big one. Like you typed the name of the field wrong, or somebody changed a field. That's a big one. Yes. Something is undefined. Yep. And any others? Those are yeah. Commas, brackets, the syntax. Okay. The syntax can get caught by the IDE now without typing information, but misspelling a field name or a property name, or passing the parameters wrong to your functions because you meant to pass 2 and you only typed or passed 1, and things like that. And undefined, dealing with unexpected undefineds and nulls. Those are by far the largest numbers of bugs in the world are caused by those, and TypeScript fixes them all. Okay, so that's TypeScript's biggest claim to fame, is it fixes or identifies at edit time probably 75% of all the bugs out there in the world. And that's a pretty amazing thing. And so it's just incredible what a big help it is and how it does that for you. Now, because of this, because it provides such a huge value, especially for writing large scale programs, as things like Node and React and other frameworks and things started getting more and more and more usage, TypeScript started to soar in popularity. So I have a little chart here that shows you how TypeScript's popularity has soared. So here's TypeScript, the light blue, introduced in 2012, 2014. It hit number 10 of all the most. This is by the way, a graph of the most used languages. I believe that this is a I can't remember. This is from Stack Overflow, or it looks like it's GitHub. I think this is a number of lines of code in GitHub repositories or something of that nature. So it is measuring usage. And so TypeScript started down here. Actually, by just 2 years later, it was already number 10, which is a pretty good achievement, but not a big deal. But then after a couple or 3 years, it just suddenly started taking off. And now it's the fourth most, in 2022, it's the fourth most popular language in use in the world, behind Java, Python, and JavaScript. So JavaScript, even though TypeScript is so much better, JavaScript's still there at number 1. Anyone know why JavaScript's number 1? Is it such an awesome language? No. Because it's been there for so long? Close. Because these other languages have been there longer. Yes, all the legacy code. Why is all that legacy code there? Yes, JavaScript is the most popular language in the world because that's what all of our browsers run, and web pages are now the most popular way in the world most popular use of programming in the world is websites. So that's why JavaScript is number 1. And TypeScript is coming up very, very quickly, and I think is going to overtake it pretty soon. And that's why it's becoming more and more valuable to teach it, because we get more and more people who are interviewing LearningFuze students asking about their TypeScript experience. So it's becoming very, very valuable, not only because it's so great, but also because it's becoming ubiquitous. So Java, I'm surprised at how popular Java is. It's probably the most used backend language, and that's why it's up here so high. And Python, why would you think Python is so popular? Easy. It has the reputation of being easy. My experience trying to teach people to use Python is that it's not easy. I don't like the language at all. I think it's a pretty awful language, but its claim to fame is ease of learning. But I was teaching high school kids how to program in Python, and it was really, really tough getting over some of the hurdles with it. So, but it's not why it's most popular. It's not ease of use. It would be. I don't expect you to know, but any other guesses? It's very slow language, so running it on the server is not a big thing. It's not used on servers very often at all. Data science, yep, which means data science, which usually feeds into AI. So for reasons I don't understand, the AI community early on adopted Python, probably because it was supposed to be easy, and they figured that data scientists could learn it. And so it was adopted really early, and so its popularity has been moving upward because of its use by data scientists. So anyway, so that's these top languages. All right. So anyway, so that's TypeScript, a little bit about why we use it and why it's what its popularity is, and why you would want to learn it. So let me talk then a little bit more about what TypeScript is and its goals, and I'll give you a little bit of a very, very brief high-level tutorial of TypeScript. And I'll conclude with some suggestions on what you can do to learn it yourself. Okay, so TypeScript is a superset of JavaScript. Every JavaScript program in existence can be compiled and run by the TypeScript. So what TypeScript does is it's actually, it examines your code, your TypeScript code, and it produces JavaScript. So it takes TypeScript, translates it into JavaScript, and then any engine out there that can run JavaScript, which would be browsers and Node and so on, they can then run the code that TypeScript produces. So TypeScript is a superset of JavaScript, and it transpiles or transforms the code from TypeScript into JavaScript. What else did we just study that does a transpiling code? Good memory, Babel. So it's similar to Babel, but you feed it in TypeScript, and it outputs JavaScript. And again, you can feed TypeScript your JavaScript code, and it will be able to successfully deal with it, parse it, understand it. And it actually does add a little bit of value onto just straight JavaScript. So what TypeScript then does is it provided syntax extensions to the JavaScript language, which allow it to do typing. So that's why it's called TypeScript. It's JavaScript with types. So you take your JavaScript, you add some typing annotations in various places, and you suddenly have TypeScript, and the TypeScript engine can then examine your code and fix it up. All right. All right, so I already said that it's most important for large projects and working across developers. Oh, another one that's another very, very common problem nobody mentioned is I'm trying to call somebody else's function. How do you know what type to send it? What type to pass to the function? You have to read the code, right? Or hopefully they have a JS comment. TypeScript helps you figure out what types of things that you need to send into a function and what types of things you're going to get back out again. So you can use that typing instead of the JS doc. All right. So the way that TypeScript currently works is they have a compiler it's a command line program called TSC, and you pass TSC your TypeScript files, and it produces JavaScript on the back end. So you use this TSC compiler. And the nice thing about it is you can also tell TypeScript what version of JavaScript you want to target. So it can target just about any version of JavaScript ever written. So if you have an engine that only runs old JavaScript, you can target that. If you're running on an engine that runs more modern JavaScript, you can target that. So there you go. All right. TypeScript is continually in continual development. Microsoft has a large team working on it, and it's continually being evolved and updated and improved, and it's still rapidly evolving. All right, so let's talk about some of the features. So according to the TypeScript site, I like this. They say TypeScript is JavaScript with syntax for types. TypeScript is a strongly typed programming language. Talk about that in a second. That builds on JavaScript, giving you better tooling at any scale. That's the JavaScript. That's the TypeScript site's claim to what they are. So a strongly typed programming language means that every variable has a type that is known at compile time. And that's what makes a language strongly typed, is all of the types are known at compile time. And once a variable contains an object of a given type, it cannot be changed to a different type. So that's another feature. There is actually a way to, well, no, you can't. So so it's a strongly typed language in that sense. And so you know what the types are of everything. And it sounds restrictive, but it actually is very freeing, because you don't have to worry about remembering, oh, what type was that? Let me go find the code and look it up. Or you guess, or you console log it and hope you see the values and you figure out from console logging. Instead, it's there encoded in the language itself. Okay. So without TypeScript, you run into typing errors. You know, you pass the wrong thing into a function, the wrong type of variable into a function. Usually, when do you find out that you screwed up? When do you find out you screwed up in JavaScript? When you run the code, yeah, at runtime. You run the code, you found out you made the mistake. It's very expensive to find problems at runtime. It's expensive for you as you're developing because you have to complete the code, get it to where you can actually run it, and then you have to go figure out, oh, wait, I have a problem here. It may be that you introduced a bug that is in code you're not currently running, so you don't see it. So then you'll only see the bug appear in production when somebody else hits it and they're not very happy with you because you have bugs in your code. So catching things at compile time is a phenomenal time saver. All right. So we talked about the, that's funny. We talked about the most common sources of bugs in our JavaScript code. In my experience, at least so I worked at a company recently where after Google, where we were writing all in JavaScript. I tried to get them to switch to TypeScript. We were in the process of doing that, but we were doing it in JavaScript, a large team of about 100 engineers, experienced. Many of them had been working in JavaScript for 10, 12 years. And the number one bug among those people, those engineers at that company, the number one bug by far was undefined. As they were writing their JavaScript code, they didn't even think about it. So I would turn on the TypeScript compiler and start getting their code, and I'd find bug after bug after bug that TypeScript would find because of the undefined. So I'll talk in a little bit about how TypeScript is able to do that. All right. Oh, I guess I'll talk about it right now. The way this works in TypeScript is they did a very clever thing. They say undefined and null are data types. So you have data types of string, number, object, undefined, and null. Those are the data types. And so you declare that my variable is a string. You say it's string or undefined. So it can be either one of those. And that way TypeScript knows that this might be undefined, and therefore it makes and checks to make sure that you're using it everywhere you use it. You're, for example, not trying to call an undefined function or dereference an undefined variable using dot on it. So, okay. All right. They also do some fun things. I'll get into a little bit of this. Often we pass around or keep state as, we often do it as an integer, 1, 2, 3, 4, 5, but it's very common in JavaScript to not do it as an integer, but to use strings. For example, my state might be loading or success or failure if I'm keeping track of the state of my my fetch request. So I'm currently in the loading state, then I'm in the success state, or I'm in the failure state. And so I'll use a string to indicate those. And the problem that happens here is the typos that Lamberto was mentioning. And because I'll misspell loading, I'll change my mind and change it from failure to error and not find all the places I did that, and I'll be messed up. TypeScript actually lets you declare a variable not just as a string, but as it must be either loading, success, or failure. And if you assign it to anything other than that, it will give you an error. So it does things like that that are just really, really useful when you're writing your JavaScript code to make sure that everything is consistent and you're using things correctly. Okay. All right. I guess I did forget to mention this one. When TypeScript compiles its TypeScript down to JavaScript, does JavaScript have types? No. So when TypeScript is done with its compilation, all the typing is removed. So it doesn't show up anywhere in the code. So when you're actually running that JavaScript, there's no type information. It doesn't know. It's just the normal JavaScript engine. So that's important to keep in mind in some cases, because you need to remember that when it's running, all your typing information that was there at compile time is gone. So that's just the way it works. All right, so let's talk about how TypeScript has decided to work with types. So the most common way to define types is what is done in, like, for the Java language and C++ language, is you define types. They call it nominal typing, but what it really means is it's type names. Every type has a name, and two types that have different names are not compatible. So if I have a type named fetch state, and I have a function or a type named execution state, and they're both strings, and I try to pass a fetch state into a execution state, I can't do it. I can't pass one to the other. They're not compatible with each other. So there's no way that these types can actually interoperate. And that's the most common way that that languages do their typing now, is you declare a type, and the type names must match in order for them to be compatible and for you to be able to pass one to the other. This can get you into some binds. It's nice, but it can get you into some binds where, you know, my two states might actually be both strings, and they may actually have exactly the same variables, but I can't interoperate them. So TypeScript uses instead what's called, the official name is structural typing, but and so what it does is it looks not at the names, they can be named anything. It looks at their structure, which means, any thoughts of what is the structure? So if I have two objects that both have a name and that have fields name, address, phone number, as long as my two objects are, my two types are objects that have name, address, and phone number keys, then they are compatible. So I can pass them to each other. So it looks not at the names, but at the structures. So it looks to say, are they both objects? Do they both have the same keys? Yes, they're compatible. Or are they these named ones where I have those three names, success, failure, loading? Are they both, if they both are declared to be exactly the same, then they're compatible, even if they have different names. And so this is often called, referred to lovingly, not as structural typing, because that's kind of a tough word to remember, but we call it duck typing. Anyone heard duck typing? Why do you think we'd call it duck typing? It comes from if it looks like a duck and quacks like a duck, it must be a duck. So that's the idea. It's duck typing. If they look the same and they act the same, then they're the same. Okay. If it looks like a duck or acts like a duck, quacks like a duck, then it must be a duck. So that's structural typing. That's the typing system that TypeScript uses. And it was very strange for me when I first started learning to use it. But now that I've gotten used to it and made use of it, I really, really like it. It's a very nice way to think about typing. All right. Then also there's generic types. I won't get into that too much, but generic types are ways to say, well, array is one that you've used right now. So what types of things can you put into an array? Anything. So you can put anything in an array. And if you're dealing with that in your TypeScript code, and I have an array, I want to know what types of objects are in it. And so generic types allows me to say, this thing is an array and it only contains strings, or this type is an array and it only contains objects of this type. Okay. So this is what generic types are used for. It's to allow you to write code that's reusable, and you can tell it that it's using different types, or what the types are. So I can write one piece of code. I can write my array code once, and it will work regardless of what type of array I pass into it, because, you know, as long as the code that I'm writing doesn't care what the actual objects are inside it. Okay. All right. So I mentioned before, you got the primitive types, number, string, Boolean, and then undefined and null are types. And then we've got the literal values of types. You can also declare object types. And then in your object types, you can say this field must be present, or you can say this field is optional. So for example, if I had name, address, and phone number, you can say this type is an object that has name, address, and phone number. And addresses or phone number is optional. So I can indicate that it's an optional field. And so when I construct one of these things, I don't have to provide the phone number. I can leave it blank. But if phone number does exist, it has to be spelled properly and it has to be of the right type. Okay, so that's kind of what it does here for object types. And then Typescript found one of their goals was to be able to let you take a big body of JavaScript code and start using Typescript on it and get it to work, and then slowly, gradually evolve your code from JavaScript to Typescript. It's amazing. So you can actually, if you decide today that you want to switch over your final project to Typescript, you don't have to rewrite anything. You just turn on Typescript. You have to rename your files from .js to .ts, but suddenly there'll be Typescript files and they'll be executing in Typescript, and the Typescript engine will work with them. And you can start adding types to your stuff slowly as you go, wherever you feel like the biggest need for it is. But one way that they had to do in order to make that possible is they were introduced to a type called any. And so you just say, this is type any. And what that says is, I don't know what type it is. I don't care. And Typescript will refuse to do any type checking on that if it's of type any. All right, and then finally, some really, really handy things is you can compose types using these or and operators. And this one means I can declare a variable to be of this type or that type or that type. And for example, with the string literals, I can say it can be of type loading or success or failure, and that's how I declare that. Or I can say it has to be a string or undefined, so it can be either of those, and that's legal. But if it's anything else, it doesn't match. And then the and operator says it's basically taking two types and tacking them together. All right. So let's go from there. Now it's time to actually get into some actual code and look at the actual syntax. So on its face, Typescript type syntax is very, very simple. And I think that actually you can go and study it and pick it up in just a few days and get quite good with it. It gets difficult when you try to write code with complex types and try to write reusable code. So that's where it's hardest. But in your normal case, in your normal code, you can do it really well. So to declare a type, I just use the type keyword. Type, this is the name of the type, equals, and then I define what it is. I can say type bar equals string, type bar equals, this is declaring bar to be an object that has two fields in it, a name and an address, both of which are strings, and the question mark here means that address is optional. So now anytime I want to use this bar somewhere else, I know when I'm writing my code that an object of type bar will have a name field and it might have an address field. So and then so if I try to access anything else like address misspelled, I'll get an error. Or NM instead of NAME, I'll get an error. Or if there's another field that I think is supposed to be on, that I think is on there, and I try to use it, I'll get an error. So this way, I'm declaring what it's supposed to look like, and it makes it really easy to write the code that always does the right thing. Okay. So it's pretty simple there. That's how you declare your types. Now, how do you use them? So you use them also pretty in a fairly straightforward way. You have your variable name and you put a colon, and after the colon you put the type. So this says that the variable AXU is supposed to be of type foo, and then I can assign it. So it will look here, and it will say, okay, type foo. It knows what type foo is supposed to be. It looks to say, does type foo have a name? It's type foo is an object. Does it have a name field? Yes. So I can make this assignment. If the type foo does not have a name field in it, then this will give me an error because I'm trying to assign something that is not a foo into my variable. So that's how you use it on variables. And then on functions, you, again, just the normal function syntax. Here's my parameter A. I again use the colon. A colon foo, B colon number. So this says that read bar takes 2 parameters. The first one has to be of type foo. The second one has to be of type number, and the question mark says it's optional. So I can actually call this with just 1 parameter as long as that parameter is a foo. If I try to pass in a foo and a string, I get a compile error. If I try to pass in 3 parameters, I get a compile error. If I try to call it with 0 parameters, I get a compile error. Okay, so it does all this checking for you to make sure that you're calling it correctly. And then finally, that's for the parameters. And then also this tells Typescript that read bar is going to return an object of type bar. Okay, and then this is the body of the function. So this actually would produce a compile error because I didn't actually return something of type bar. So this line of code right here wouldn't compile. But if I it has to return an object that is of type bar. So that's how the syntax works on it there, and it does all that type checking for you. Okay. Another thing that's interesting is that Typescript does what we call type inference, which means that it tries to figure out your types. So you actually only need to go in and put your types in maybe 10% of your code, and the rest of it, Typescript just figures it out. For example, it can look at this, and it knows a number of things. First of all, what does it know about AXU? What type does it have to be? It looks at the read bar definition from what I had up here. What type does AXU need to be? It's a type foo from up there. So it knows that it knows that AXU is of type foo. It knows that read bar accepts something of type foo. So therefore, it says, yes, those match. It will compile. And then it looks up at this and it says, okay, read bar returns something of type bar. So now Typescript knows that what's the type of B. Okay, so it knows the B is of type bar. So here I can do this call and I can make here, and I don't have to do any of the type. I don't have to type in the types or anything. It's already figured out the B is of type bar. It's already figured out that AXU is of type foo, so it can be properly passed in here. So it uses this type inference very aggressively, and it makes your code much simpler. Okay. Generic types we won't talk too much about, but I mentioned that. So here's an array that holds objects. Everything in this array must be of type number. So I use the angle brackets here to indicate that. Okay. Here's an example of how you do the literal types. So for example, this one is defined HTTP method. You remember what the HTTP methods are? That you pass into fetch, get, post, put, and so on. So if you declare this type HTTP method, this says an HTTP method can be one of these 1, 2, 3, 4 strings. If it's anything else, it fails. It doesn't match. And then I can write my fetch call. I can declare it as taking a method, which must be of type HTTP method. And then my URL, which can be any string, and a payload. And we use this special type unknown, which means I don't know what type it is and I don't care. Typescript will make sure you don't use it improperly. So now we know from here, when I'm writing this code, I know without doubt that method is one of these 4 strings. I don't have to check it for anything else because I know it's going to be one of those strings. Otherwise, it would have got a compile error. I know when I call it, if I try to call it with head, that's another method that's not declared here. If I try to call it with head, I'll get a compile error and it won't let me do it. If I misspell these, like suppose I do lowercase instead of uppercase, I'll get a compile error, and it won't let me make that call. So this helps you avoid all of these typos that you were talking about, because the compiler just goes and checks them all for you. Okay, and then quickly I'll show you how undefined is used. So here I'm using, remember, the OR operator. So here I'm declaring a function called findFoo. Takes how many parameters? 1. And what must that type be? The type of that parameter? A string. And it returns, findFoo will return either a foo or undefined. So now TypeScript knows that when I call findFoo, I might get back undefined, and I might get back a foo, but I won't get anything else. And so now it knows that if I accidentally, I'll show you some code down here. So we know inside of here, we know that name must be a string. So I don't have to worry about checking to see if it's undefined. I know it can't be. Otherwise, the code wouldn't have compiled. So I know foo is a string. And so I can now look at my foos variable to find somewhere else and call find on it. And I know that my foos is defined somewhere else to be an array of foo. So I can call find on it, find one, and check the name. I know that f.name exists because my foos is a foo array, and foo I've declared to have a name field. So it checks this to make sure that's legal. It checks that foo, that it knows that this is a string. It knows that this is a string, so I can do that comparison. So all those checkings are done for me right here to make sure everything's working properly. And now when I call it, I can just call findFoo. So I'm calling that function up there. The compiler knows, TypeScript knows what's the type of f. It's either a foo or an undefined. So this will give us an error. Why? That's one reason. I put age. Age doesn't exist in foo. So it will complain because of that. And it will also complain here on f.name, even though name exists. Why will it complain? Because f might be undefined. Remember, f can be either foo or undefined. If f is undefined, what happens in JavaScript when I say f.name if f is undefined? You get a type error. You say, I can't look up property name on undefined. You've seen those a zillion times, I'm sure. So f.name is not going to be, so the compiler will catch this. I don't need to worry about the fact that this has a bug in it, because the compiler will catch it. TypeScript will catch it for me, and I'll know, and I'll have to fix it. What's one quick way to fix it? See how well you learned your ES6 operators? How can I fix this? First one, f.name. Close. f?name is the quickest way to fix that. Okay. And then this one, there's no fix for that because age doesn't exist. Okay. Yeah. So you delete it. Or you go, whoops, it's not the type I thought it was, and you fix your code. All right. So that's a basic rundown of TypeScript and how it works. That just enough of an introduction, hopefully, to get you interested in going out and learning it on your own. And then you'll be able to pick up the tutorials and things and start understanding what the code is doing and how it's working, and at least have it in your mind. I put together a list of, having used TypeScript for many, many years, I put together what I consider some of the best practices for using TypeScript. And then, these are in my opinion, in my extensive experience. Okay. All right. So here you go. Use type inference as much as possible. What's type inference? Do you remember what that meant? That's when the compiler figures out the types for you. It infers the types from the code. The type inference is the compiler figures out the code for the type for you. So don't declare your types everywhere, because it just makes your code harder to read. And just let the compiler figure it out as much as you can. All right. Oh, this one I didn't talk about, but there's also a thing in TypeScript called interface. and you can declare your types either using type or interface, and there's a big controversy over which one you should use and how they differ. My personal opinion is that you should never use interface. You should always use type, though the TypeScript documentation actually disagrees with me. But they're wrong. I'm right. All right. There's also another TypeScript type called enum. If you run across that one, I suggest you never ever use that again. And instead you use literals with the or operator. So again, you probably don't understand that one. But this is something you can come back to after you're a little more comfortable with it and use it. All right, here you go. Keep your types simple in your client code. Just, foo or undefined. That's about the only time you want to try and get complicated with your code. Just keep them very simple and declare simple types. If you're writing code that's going to be used by other components, then your code types might start getting more and more complex. And they actually can get complex. And if you're using some that has complex types, it can be hard to figure out what you've done wrong. This is one of the problems with TypeScript is as you're starting to use GitHub stuff and it has complex types in it, you can get confused. But the TypeScript compiler does give you good messages. If you have an error and you hover over it, it'll give you a really good description of what exactly is going wrong. So use that. There's also a strict mode that TypeScript offers. If in strict mode, TypeScript will make sure that your undefineds and nulls are not dereferenced. So it'll catch all your undefined and null errors for you. A lot of people like to turn strict mode off when they're transitioning into JavaScript because there's so many bugs in existing JavaScript code that they can't get it to compile. And so they turn strict mode off, and then they end up having undefined and null dereference bugs. And so if you're going to turn it off to start using it, turn it back on as soon as you get comfortable with it. So use strict mode, and then you can use any. Use any wherever you can if you're just trying to get things going and you can't figure out what the right type would be, make use of it. But over time, there is an option in TypeScript that says no explicit any, which means I cannot explicitly use the type any. I can't type in this is of type any, and it will give you an error. So you want to turn that on so that you get rid of all of those and you're making full use of the typing everywhere. All right, and then, okay. So those are the main ones that I like to do. So TypeScript is great in that it is easy to pick up and get started with fairly easily. Like I said, you can take an existing JavaScript program, do all the proper installation things to get it working with TypeScript, and then you can you can just then start adding types where you wish, slowly and gradually. It's a very good thing to do. The error messages and the guides in your IDE will help you along, and it's a good way to get going. So sometimes the error messages that TypeScript gives you can be hard to chase down. Just a tip that you won't make sense now, but when you see these big long errors of why your type doesn't match, I like to start at the bottom and work my way up and then figure out what's going on. But usually it's something simple. All right. And then as you gain more experience, then you'll go and turn off your innies and so on and get better at it. So what's this one for? Uh-oh, after you. Oh, okay. This is a what we call a type assertion. Most languages call it a typecast. But suppose I'm trying to pass this bar function expects a foo, and I can't, and f is not a foo, but I know that it should work. You can just tell TypeScript to consider it as one anyway, and then it'll go ahead. And if all else fails, then you say as any, and this will let you pass anything in there. And you're at your own, you're taking your risks, and you're making sure it's right, but at least it lets you get the code in and get moving forward and not get hung up on TypeScript. When you're using TypeScript, especially early on, don't let it slow you down. Instead, use it to its advantage. And if you run into problems, you can do these tricks in order to get past any blockages and then later come back and fix it up. All right, so that's really it that I'm going to talk about. But there are some links in here that I think are very useful. So if you want to go off and learn it on your own, like I say, I know I've said it in this class before, but I didn't say it in this lecture. I'm just going to say again, I can speak. I can fluently write code in probably 6 or 8 different languages. I can read probably 15 or 20. Of all of the languages I've learned over my career, TypeScript has become my absolute #1 favorite programming language. And so it's strongly, strongly recommended. And I love it. It's a great language. It's a joy to work in. And so I really think that you should take the time to learn it. The best way to learn it is to just go to the TypeScript site. It's called typescriptlang.org. And they have phenomenal handbook, and there's a phenomenal handbook, phenomenal tutorials. One of the best ones for you is you're familiar with TypeScript. They have one is TypeScript for JS programmers. So it's just a very quick introduction to TypeScript for people who already know JavaScript. A great introduction. It'll be easy for you to read. It'll pretty much reproduce a lot of what I've done here and then go into more detail in various areas. But it's a great, great, great way to get started in the language is to go read this TypeScript for JS programmers, and that's on the TypeScript language website. Okay, and as you get going further, I found a site that I found was very useful. They get hard very fast, so you have to be a little careful. But there's a site called TypeScript Exercises, which will give you a problem to solve. They produce the JavaScript code, and then your goal is to put in the typings in the right places. You don't modify the code, you just put in the types, and then it will run a unit test against your solution and make sure it's right. And if it's not, it will try to give you hints as to what it is you've got wrong and how you can fix it. So I found this is a good way to increase your skills and improve your skills is using this. But again, they get hard really fast. So be a little aware of that. Okay. So that is it. Any questions on TypeScript? All right. I think, Brett, that we're done.
Awesome. Sounds great. Thank you so much, Robert.
All right. It was almost an hour. Okay. All right. Take care.
All right. Have a great one. Thank you.